Section 1.4 is a pretty small section. We're only going to look at two objectives in this section. The first one is to compare numbers using inequality symbols. And inequality, if you take it apart, it has the word equality or equal in it. So equal means something is the same. Inequality is going to mean something that's not the same. And since we're talking about numbers, the way that numbers usually differ from each other is by being bigger or smaller. So these inequality symbols tell us that if they're placed between two numbers, that those numbers aren't equal to each other, they're unequal or they're an inequality, and which one is the big one and which one's the smaller one. So we called this symbol the less than symbol. So when you're saying it, when you see it in a math problem, you're going to say is less than. Okay. The one that goes the other way is the one that means greater than. So when you see that one in a math expression or equation, you're going to say is greater than. Okay. And when you're going to place these into a statement, so they want us down here to put in the correct inequality to make the statement true, we're going to go all the way back to my second grade teacher, Mrs. Green, who in the time when I was in second grade, yes, Pac-Man from Atari was the big game, and she taught us to eat the one you'd rather have. Okay. Or eat the big one. So you can think of these inequality symbols as being like Pac-Man. So if we're looking at the difference here, as adult students, Pac-Man may not be the most applicable example. So I'm going to talk about something that might make a little more sense to all of us. Money. If we're looking at the balance in your checking account, and you have to pick whether you would rather have one balance or another, I'm guessing you would rather have the one that's more money, and the one that is not a negative balance, because negative balances are not so fun. So when we look at the difference here, if we think of these as being money, difference between $1 or having a balance of negative $4, although $1 is not a lot of money, it's better than owing the bank $4. So we're going to have the Pac-Man eat the 1. And we would say this statement, 1 is greater than negative 4. Okay. Putting the inequality statement in here, given the choice between a bank balance of negative $3 and negative 2, well, I'm sure we'd prefer not to be negative at all. It's better to only owe the bank $2 than to owe them $3. So we would say negative 3 is less than negative 2. And in this last one, given the choice between owing the bank $2 and having $2, we'd much rather have $2. We're going to go ahead and do objective 3 on the same video because this is a short little one here. It's just two vocabulary terms that we're going to be using in the next section. Additive inverse is just a fancy way of saying opposite. Or if we want to give it a more mathy definition, it is a number the same distance away or I'm going to say the same distance from 0 on the other side. Okay. So if we think of a big long number line here, with this being 0, and 1, 2, 3, 4, 5 going that way, negative 1, 2, 3, 4, 5 going that way. negative 3 would be the additive inverse of positive 3 because they are the same distance away from 0 on the other side. Okay? And likewise, a positive 1 is the additive inverse of negative 1 because positive 1 is the same distance away from 0 as negative 1 is, if I make a really straight number line, which we're going to pretend that is. Okay? So it's pretty easy to find additive inverses. The hardest part of this skill is just remembering what the word means. Okay, so if they ask you for the additive inverse of 6, you're going to say, well, that would be negative 6. The additive inverse of negative 1 would be a positive 1, and we don't need the positive in front of it. Any number that's just doesn't have a sign is assumed to be positive. And the additive inverse of 1/2 is going to be a negative 1/2. Our last vocabulary word for this section is absolute value, and it also has to do with the distance from 0. What it means, the absolute value is the distance a number is from 0. Okay? And because we're talking about distance, not the actual value itself, but the distance it is away, distance is always positive. Because even if I walk all the way to school backward, or in a really bad mood, a really negative mood, the distance I'm traveling is still going to be a positive distance. You can't have negative distance. The symbol that we use to show absolute value is kind of like parentheses, except that they're straight. So when you see these straight lines with some kind of number on the inside, what they're asking you to do is to tell them how far is whatever's inside here away from 0 on a number line. So looking at our first problem, this is saying what is the absolute value of 12, or how far away is 12 from 0 on a number line? Well, it's a distance of 12 spaces. This one's asking us how far away is negative 18 from 0. Well, even though I'm coming from the negative side over here and traveling toward 0, I'm still traveling a positive distance, so negative 18 is also a distance of 18. These next two are where it might get a little trickier. So looking at the absolute value of 9, well, 9 is 9 away from 0, but the negative sign is going to stay there because it was already outside the symbol. So what they're asking us is, tell us what the opposite is of the distance that 9 is from 0. 9 is 9 away from 0, and its opposite, or its additive inverse, is going to be negative 9. And in this last problem, the absolute value actually function like parentheses. Remember in order of operations? So we're going to do the math that's inside here first, and then find the absolute value of our answer. So we take 16 and subtract 13. That gives us 3. And the absolute value of 3, the distance that 3 is from 0, is still 3.